So this is part 2 of species habitat model or species distribution model, and what we're doing today is that we're going to map out the habitat for Sebaceous nemoi, or Finding Nemo. So in other words, we're finding Nemo like the movie, which is kind of cool. You can see here, these are our 4 data sets that we're going to be using. Multi-beam bathymetric grid for Caramel Bay, a hillshade grid for the same area, a rugosity grid to calculate, let's calculate using the BTM modeler tool that's available on the zip file, and then the zones, the benthic zones, calculated using the same modeling tool. And we're going to be using Spatial Analyst extension in ArcMap 10.1. So the basics is that we're going to take our different parameter grids, or take our different informations, and we're going to use that to create parameter grids of zeros and ones that we're going to use afterwards to calculate our model. So the first one we're going to create is going to be a 30 to 50 meter depth, going just off the bathymetry. Then we're going to create a grid representing high rugosity areas, so very rough areas, by taking our rugosity layer from the BTM. And then we're going to take another grid that represents high bathymetric position area, so ridges, and we're going to use or crests in this case. So we're going to use our raster calculator to calculate those things. So the first thing that we're going to want to do is go ahead and launch up ArcMap. So I'm just going to go to my start menu and I'm going to find ArcMap 10.1. Of course, if you can't find ArcMap, you can always just type it into your search and find it. So ArcMap 10.1. Once it gets launched, I'm just going to go ahead and browse for more MXDs, and I'm going to look at my desktop where I have my SDM folder. This might be on your H drive, but then once I get that, I'm going to do my Caramel Bay or Caramel Bay. Go ahead and open up this MXD. Once it opens up, you'll see that you have 4 different layers. One's the rugosity, one's the caramel hillshade, the other one's the caramel bathymetry, and then we have our different zones, our benthic zones. And you can see here, like for example, the ROV paths as they go to collect the bathymetry data, or the hillshade data in this case. And you can see they each have different extents. For example, our bathymetry we have for a smaller extent than our hillshade, but that's not a problem, which we have a smaller extent for our zones, and then for our rugosity. So we can see rugosity, what it looks like too, is kind of cool. So we have a whole bunch of cool information here, but we're going to want to use these and parameterize them for our model. So the first thing we're going to do is make sure our Spatial Analyst extension is on. So I'm going to do Customize Extensions and verify that I have that checked on, and I do have this checked on, so we are good to use all the different tools that we'll be needing in the raster calculator. Then I want to have my ArcToolBox open. I already have my ArcToolBox open here. Sometimes you'll find it docked here, and you just click it. You can always use this thumb tag to dock it and have it always open. But if you're having trouble finding your ArcToolBox, you always can click on this icon with a little red toolbox on it. That's going to open up your ArcToolBox. In our ArcToolBox, you see that we're going to have multiple toolboxes. I'm going to choose the Spatial Analyst tools. And then I'm looking at the tool set called Map Algebra. And in here, you'll see the raster calculator, and that's what we're going to be using today. So just go ahead and double click that. Okay, so now that we have our raster calculator launched, what we want to do is first take the bathymetry, and we're going to say the preferred habitat lies between negative 30 meters and negative 50 meters below sea level. So that's our 2 kind of bookshelves. The Nemo is not going to be found below that depth or above that depth. So what we're going to do is we're going to say open parenthesis, and we're going to say caramel bathymetry must be less than negative 30, so below negative 30 depth, close the parenthesis. And what we're going to want to do now is use the AND condition, and that's going to say like this has to be true, okay, and then what other condition has to be true is that and go ahead and open parenthesis again, that caramel bathymetry is going to be greater than negative 50. So if it's like, for example, -40, this condition will be met, so this will be true, and then this condition will be met, this will be true. So this whole statement will be true, and then therefore it will output as a boolean value of 1, which that's going to be true. Then on my output raster, I want to make sure that I save it somewhere good, so I'm going to go to my SDM folder, and in here I'm going to call this bath I'm going to call it, actually I want to call it depth 30 underscore 50M. This is, I'll know, oh, actually I already have it saved here, so I'm going to call this number 2. So depth 30 to 50, I know that this is going to be the distance, you know, I'm trying to name it something that I'll know what it means afterwards. So always try to do that with your naming conventions. So I say OK, I go ahead and OK, and I'll let it process. Whenever you're processing, you'll see here this raster calculator reacting. But one thing that you also do is go to the geoprocessing results, and in here you'll see the current and past raster, like anything from the toolbox that you've done, including messages. So like for example, here's this raster calculator session that I did. If I double click it, I can see that's the one that we did. It tells me my outputs, my inputs, here's my map algebra expressions, and you can see here the information about how long it took to process. So here it was 8 seconds to process. So here's my results, depth 30 to 50 meters, and if I zoom to the layer, you can see here pretty much what it did was say that this zone right here in this entire area, only this zone is the zone that can contain Nemos. Okay, everything else will not work. So over here you have maybe too deep, or over here you have too shallow. So this is just far away enough from the coast for this to happen. Okay, so we're done with bathymetry, so we can turn this off. So we parameterized that. So this is true, value of 1. These are false. Okay, so we already have that in our model set up. The next thing that we want to do is parameterize the rugosity. So for rugosity, so let's go ahead and turn this depth off and see what the rugosity looks like. So this is what our rugosity looks like. These are going to be values of how rough the, let's turn the sill shade off. There we go, how rough a certain area of the land is. And what we want to do is we want to have values that are greater than 1.2 rugosity. So what we're going to do is again parameterize this by using the raster calculator. And we're going to say here rug is greater than 1.2, and this is going to, again, if it's this expression is true, it's going to come up with a value of 1. If it's false, it'll come up with a value of 0. So I'm going to go ahead and save that. I'm going to call this rug 1.2 underscore 0. And then I'm going to hit OK. So again, my process is going on. I can check out my results. I can see here a little hourglass saying that it's going through, and the calculation finished, and here now it has put in that information. I can also dock this since I find it important. I can dock my results, and so I can refer to it quickly by just clicking here. So now you can see here that areas with 0 are lower than 1.2 rugosity, areas with 1 are higher rugosity. So these areas would be areas that are interesting habitats for Nemos. These areas will not be. So nice. So now the next step is to parameterize our other results. So we want topographic relief. We're going to want our zone, the zone for here, our zones, benthic zones. We want it to be equal to 1. Zone 1 is going to be the zone that's most interesting for us. So what we're going to do here is going to parameterize this to only get zone 1. So again, we're going to say raster calculator. We're going to choose zones, and we want it to be equal to 1. And then again, make sure I output this. And here I'm going to say zones 1 underscore 0. So here, where zone is 1, it's going to equal 1. When zones 2, 3, or 4, it'll equal 0. So true or false. So we say OK. Again, this thing, so we can check out our results. You can see it's processing here. And we can see for our messages, it was successful, so it was. And we can see here, the areas were 1. That's true. So now we have that parameterized. So now that we made these 3 different parameters for our models, and these here we're done with. I'm just going to leave them checked off for now. But now that we've made these 3 different layers, these are the 3 parameters for our model. And so we can use these to predict the habitat for the fish. So again, we're going to be doing 2 different types of models. You can see from the handout, we're going to have a ranking model and a binary model. And the only differences between the ranking and the binary is if we have pluses or if we're using multiplication in our raster calculator. So let's do the binary model first. So we're going to launch the raster calculator. And what we're going to do is we're going to multiply the 3 layers together. So we're going to say zone 1 times the rugosity times the depth. And what's in up here, if this is true and this is true and this is true, it's going to be 1 times 1 times 1. And then we'll have equal to 1. And that would be good habitat. If one of these happen to be false, the value will be 0, and that will add a 0 into this expression, causing the whole expression to multiply out to 0. And then we know that becomes bad habitat. So we're going to want to output this, and I'm going to output it here, and I'm going to just make a new folder. And this one I'm going to call binary bin, and I'm going to call it 0. I usually like starting my first attempts with the number 0, because if it fails and I have to redo next attempt, I can just iterate that number to 1, 2, 3, and I know what the latest version was. And normally the last version is the one that was successful. So I'm going to hit products 2 and then bin 0, okay? And again, I'm processing so I can check out my results. And I can see here from the results, up here at the top, it's running and it's calculated through. So then we have our resulting raster with our values where everything is true. I want to do the same thing though, but this time with the ranking model. So if I actually double click this raster, it's going to bring up this raster calculator. It's going to bring up my last one. And the only difference here is instead of multiplication, I'm going to do addition. So I can just actually highlight these, change them out with addition, and then here I can call this rank 0 and hit OK, and then run that next raster calculator. So now that they resulted, we have 2 different models. We can just turn off now our parameters and look at the 2 different models we have. And here, for example, here's ranking model. 0 would be completely not habitable habitat. It doesn't meet any criterias. And then you can see here 1 would meet one of the 3 criteria. So these areas would have here, for example, the right depth. But then you have here the 2s, which are the greens. Those are going to be areas that are 2 out of 3 parameters met. And then finally the light blues, which would be the 3s. And you can see there's small areas here. You can change the color of these here if you go to properties. And here, of course, you can change these different colors to find different gradations. Maybe something that goes from lighter to darker, for less suitable to more suitable, would be a good idea. Kind of shows the gradation of how it gets better and better. Another thing that you can do is also open the attribute table, and over here you can see the counts of pixels. For example, here number 3 has 3,208 pixels that are the best, best habitat, meet all parameters. And if I look here under the properties for this layer, and I go to my general information, or source information, I can see here my cell size, which is saying it's 2.05 by 2.05. And that's going to be in meters. So it's 2.05 meters squared. So if I took this number 3,208 and I take my calculator and I say 3208 and I multiply it by 2.05 and multiply it by 2.05, I have here 13,000 square meters of habitat that's available for the Nemo in this study area. And if I took the total number, of course, I can find out how much habitat percentage-wise is available for the Nemo. If I go into statistics here, I can get all these numbers added up together. So, for example, here's the sum of 535,802. So if I go here and I take this number and I divide it by 535,802, I can see that I have 2% of this area is good for good habitat for this fish. So if we protect this 2%, that could be the spawning grounds and would help for the sustainable fisheries act to protect our fishing populations. So 3 out of 3, but there's also, if say we want to be more conservative, we can protect 2 out of 3 in the ranking models, and we'll get more habitat protected. But maybe we'll find out that the fish preferred habitat would be a perfect depth and perfect rock bottoms with nooks and crannies. But if it's at a great depth and it has good good rock bottom, that might be good enough for the fish. Or if it's at a perfect depth and has nooks and crannies. So 2 out of 3 might be good. So we can decide where to put this cutoff, and that's going to change how much habitat we have. With the binary model, we're kind of assuming that all parameters are 100% necessary. We can see let's change this color to something that makes it a little bit easier to see. But here with the gray background, you can kind of see better. And maybe I can change this to like a brighter red. So you can see now the habitat. We're saying that all habitat here has to be, all parameters have to be met, or the fish won't survive. So here we're saying that this area has to be protected. And if we look at the counts for our, true, we're going to see that it's 3,208. Exactly the same for the binary of 3. For the ranking model where it was 3. This is because in ranking model, pretty much having all 3 parameters met is saying 1 times 1 times 1. So it's the same as the binary model. So you'll see those two different things as equal values. Ways we can validate the model, we might want to validate the model, is that we can actually compare these models with our parameters. So we can say, okay, look, does this match up with the depth? So I can take here the depth, and I can come over here and turn this on and say, okay, this seems interesting. It is kind of following that pattern, and see where all the 4 different values meet. So I can turn all these parameters on. So here's my parameters. So see, I turn all my parameters. So all my parameters are on, right? And I have my ranking model here at the very top. If I take my info button, I'm going to quickly verify this. I'm going to click on any area of the map. And of course the info button is going to tell me what's underneath my mouse at that particular spot. And you're going to get the value. So rank model was 1. If I switch this to all visible layers, and I re-click, you can see my rank value was 1. And then you see here it tells me the parameters 0, 0, 1. So 1 plus those 2 zeros should equal 1. So I can verify that the model worked. You see, if I click on here say, okay, 3, 1 plus 1 plus 1 is 3. Now I can do the same thing with the binary, make sure that that worked out, and click an area, binary value of 1, so 1 times 1 times 1 is equal to 1. So my model is working. To truth it in reality, you would have to actually go to these habitats and see which habitats have species presence or not. So you want to go and find presence and absence data, and you might be able to find out, does this model work well? Are those the main parameters for the habitat? So all the steps we did were like step by step, clicking on here, but we don't have to use the step-by-step method. We can always use a ModelBuilder. So if we go to geoprocessing and choose ModelBuilder, this gives us kind of a workspace, a sandbox to make our models in. And what's kind of cool about this is that you can make a single model that you can insert in your different parameters, and it runs through. So for example, if I click here on ArcToolBox, I can say, okay, first thing we did was parameterize our information. So I can say here, raster calculator. And that brings my raster calculator into my ModelBuilder. And the first step that we did is that we took the bathymetry data and we took between 30 and 50. So if I double click here, I can actually choose out my same parameters and create a model. Let me see if I go ahead and delete this one. Another thing that you can do is you can go through the raster calculator that you used here. So for example, you can see that we've used raster calculator a few times. So if I bring raster calculator here, it'll have what I did. So here's this bathymetry value, and if I double click here, you see bathymetry values are equal, less than 30, greater than 50. And so I can just go ahead and drag in my different parameters, my different tools that I used. Not this one. Here's my rugosity, and here's my zones. So this was the 3 tools that I did, and then here's the 3 output rasters that happened. What I can use with those output rasters is that I can use that with the raster calculator again, of course, with where I added them together. So I can add in my raster calculator, and what's cool about this is that I can say I can connect the lines here. So I can say this one goes here, and I can say map algebra expression. This one here, map algebra expression. And so I can see here output raster 3 plus output raster 2 plus output raster. So now we made our model that did our addition. We can also do the same model, and instead this time do the multiplication. I can do the copy and paste. And here I can change this from plus to multiplication. Okay. And the only problem that we have here now is these output rasters are going to have these, we've already have this saved as something. So you want to change the name of this to 1. But what's cool about this, you're going to like this, this is really cool. I think change this to, okay, let's change that to 3. You don't have like save errors. And change this one to 2, why not? So once you have your model built like this, I can hit play, and it's actually going to go through and run all the different steps we've done. So this is like something where you can build a very complex model, see visually how they interconnect to each other, run it on these 3 different data sets. But then once you have your model finished built, you can run it, for example, a whole coastline. on a whole bunch of data sets. So you see here I failed to calculate raster here. Something bad happened here. Oh, because the output, since I changed the names. So we're going to come here, we're going to say zone 1-2 plus raster calc 3 plus rugosity 12.1. You don't need to run your model whenever you're preparing the lab. I just want you to actually create this model just to know how ModelBuilder works, since we've already done the calculations. But for this part, I do want to at least see if it's going to work. Times and times. So now this is running again. That's pretty cool, picked up where it left off, and it's doing the calculation. And let's see, right now it's on this one, the red. And then it moves on to this next one. And what's cool about models is that you can save them and send them to your friends, and they can use it to create. So you can say, hey, look at this cool ranking model that I did for Finding Nemo, and you can send it to them, and they'll be able to run it on their own side to continue the test. And these models can get very complex, and of course you can have hundreds and hundreds of tools, but this way you're kind of building off the tools that already exist. So now this has been completed, closed, so these data sets actually exist now. So if I go ahead, and I'm just going to copy this and add strange. Oh, I've never connected to it before. Let's see. So I navigate to my default geodatabase, and here's raster calc 1, and this one is, oh, well, they were both called raster calc 1, so I'm not sure exactly what happened, if it rewrote over it or not, but let's hit add. And you can see here my raster calc was created. So it's just a way that you can automate your workload. Whenever you're doing things like on a single data set, it's always better to just do hand by hand. But if you're doing this on multiple data sets, you might want to use ModelBuilder to speed up your work. So just get a screenshot of this. It's also kind of cool for whenever you're trying to explain what you've done. I'm just going to go ahead and snip this with snipping tool and try and explain what you did with the lab. You can just go ahead and save this capture. So that's how you do ranking model and binary models to do for species habitat modeling. It's just basically a raster model, which we've used many times in class, but the only difference is the parameters here are going to be habitat parameters. And then afterwards you want to test that habitat that you created virtually to see if the species do exist there. Applications for this could be to conserve land that would be good for species, or to find places to reintroduce species into. So there's a lot of conservation applications for this. This may be also to understand better the distribution of species. So that's it, and have a good